Right, so if we start with this game for the Samcape, I'm going to call it, cunningly enough, since we're doing Pac-Man, I'm going to call it Pac-Sam. In this folder, I'm going to create another folder for source graphics. I'm going to create another folder for data. That should do for now. Tools, I've got Simcape already downloaded. Graphics converter is in here. What I'm going to do, I think we need those. Rather than, what I tend to do is I could use the tools directly from this folder. When I'm doing a project, I tend to, sometimes I'll copy the entire code for the tools into the project folder. Other times I'll just copy the executables. The main reason for keeping the executables at least with the project and not just using a global copy is over time my tools update. I change them, tweak them. Occasionally it may break older projects, and it's really annoying if you want to go back and just make a tweak to an old project that you can't because the tool isn't working. So if you take a copy of at least of the executable, you can always update it when you make a new copy. When you update the tool, you then copy the new executable in. If it's working, that's fine. But as I say, it's nothing worse than 6 months down the line coming to do some changes to the project and realise you've broken your tools, and then you've got to redo a lot of stuff. So that should do for now. I'm going to use Visual Code for this. Normally I'd use Visual Studio and much more batch files, but I know a lot of people like to work from Visual Code, so we'll try and do that. Two extensions I've got are Batch Runner, which allows me to just run batch files. I'm a big fan of batch files. And PyZ80 assembler from Simon Owen. Very useful little tool. The only change I've made is I've put my path to Simcape so I can run the files directly from here. The one thing you do need to do if you've got spaces in your path name, you don't put quotes around it, as I found out. You have to put this little symbol, like the apostrophe style symbol, in front of the spaces, otherwise it won't work. So if we create a new file, here's my Pac-Sam. I tend to put a header at the start, so we'll just quickly do that. Put the date so we know when we started it, and we can also update it. Description. It do actually is. I think, as I said, my graphics tool, I do like to have things lined up. Main project file for Pac-Sam. Notes. Haven't got any at the moment. Okay, I'm not going to explain too much about Z80. For those that aren't familiar with PyZ80, we've got a dump command. This is where it's going to dump this piece of code, and we've got an org. So I'm going to dump it into page 1, offset 0. So it's basically starting at the beginning of that page. Page 1 of RAM is at address 8000, so I'm assembling this to run from address 8000. And I'm going to put auto exec, just so we can just check this is the basics is starting up. We can just put a jump to the start in. One important thing that I keep getting caught out about, and I might see if I can tweak the PyZ80 plugin. When you hit F10, it doesn't automatically save the file. So if you make changes, remember to save the file. I've been caught out wondering why things haven't changed and haven't worked, because the file's just sitting there unsaved, so it assembles the wrong version. So that's assembled. All I do is press F10, it assembles it. Because I've set up the path to Simcape, I can press Control F10. Presto, boots up Simcape. If I go into the debugger, always stops in the interrupt, which is fine. If I step out of that, here we are. We're sitting in our nice little function, start. RAM page 1 is in memory bank C, and we're just sitting there. So not the most exciting program in the world, I know. But at least we can see that what we've got here is now running through. Now, if we go to our source graphics folder, what we should find, already put it in there. Here we go, here's the maze. Already set up, this is what we're going to be working with. If I go into promotion, you can see it's actually Simon Owen, I think it was, done a good article on putting the arcade version running on the SAM of Pac-Man. He was the one that sort of I've grabbed these graphics from to save me some trouble. He's gone to the hard work of working out the best size for each tile is 6x6. It's a horrible size in many ways, but it doesn't really make much difference what we want. So as you can see, this is the maze all cut up and built up with 6x6 blocks. For those of you that have been following my video series on the tools, on the graphics converter, you'll know we've put in a mode to cut up these tiles. So what we'll do is we'll create a new file called script. This is script to convert graphics for Pac-Sam. First, load the tile image. So you want to load source graphics maze.png, and then we next need to cut it up. So oops. First thing I want is a blank tile. Pac-Sam, let's call it maze tile. This is the tile set name, and these need to be 6x6, and it's going to be color 000. Right, now we want to grab the standard power, the standard pill. If we look here, these are 6x6, so if we grab one that is x6, y6, we can grab a standard pill graphic. So grab tile. This is so I know that the tile, when we start looking at collision and picking things up, anything that's tile 1 will be a standard pill. And we grab a power pill, so we want to grab tile, again into the maze, and this will be 6 across and then 6, 12, 18 down. And again 6x6. So I'll grab the entire maze, so grab tile map, maze, and we'll use the maze tile set. And again, they're 6x6. Up here, grab the palette. I think should be right. Now we should export everything, so we can just output all ASM to data maze.s. And now what we can do is we can create a new batch file called convert graphics.bat. In here I want to go tools stroke tool slash gfx converter .exe, and we just want to pass in script.txt. Hopefully, if I go to close that one down, so at any point if I click on here, because I've got this batch file run, I should be able to just click here. GFX converter is not recognized. It's in a folder called GFX converter. Probably need some more files. Okay, so I just need to go and grab a few bits and pieces for that. So if we go to graphics converter, I'll just take the entire folder, it's probably easiest. Okay. Grab file map. I should hopefully run it again. Okay. So you see, we load the graphics, grab the palette, grab the blank tile, grab the tile, grab another tile, grab the tile map. So if we look in data, here's the output from our thing. We've only got 5 entries in our palette at the moment. It's fine. We could force it to be 15, but 5 is fine. As you can see, our tile set 6x6 is 34 unique tiles. Our maze width and height is 28 by 31. And here, as you can see, the tile sets. So these are the graphics. First one will be our blank tiles. Then we've got our power pill tile. Then we've got also our standard pill tile and our power pill tile. Just notice that it actually doesn't pad this properly. Worry about that later. And then our maze. So you can see it's hard to see. Really, what we need to do is be able to set how many entries it put, because it looks like this. Like this is the first wall, so we know 0, 1, and 2 have been used by blank block pill power pill. So the first block it grabbed was block 3. So block 3 will become this one here, and then we go on to block 4, which will be these ones across here. So 4, 4, 4, 5, and 6 will be these ones here, and then it'll go back to 4, 4, 4, 4, 4, 4, 4, 4, 4, 7, then 8, and then here you can see we now use onto tile 1 because we grabbed that as tile 1. So it's tile 1 is these power pills. Okay, so we've grabbed all this data. Let's do a very quick test. So again, just so we can just check that everything's working, and the graphics converter's grabbing what we want. So we do HL. Normally I put these, we will put all these in nice functions at one moment, but for now, maze plus 15, LD B, 15, LDC, 248, I think it is. SAMQA Technical Manual, very useful, 248. Again, what we'll probably do is put some defines for these things. OTDR, so that should set our palette. We run backwards while we add 15. Let's try drawing a block to start with. So now, draw a tile. So we'll quickly start to build up. Render. Let's call it render. Draw tile. I'm going to hard code this to 6x6. We could write a generic one, but generic becomes slower. So you can have a generic and as well as other ones. We're going to need to render 6x6 tiles quite a lot. Now we could, what I probably will do, we've got the tile set for the maze, 6x6 pixels, so it's 3x6, so it's 18 bytes. It's not a nice number. So what I might do is in here, have lookup tables. So I have some lookup tables to make things easier. Maze tile lookup. For now, I'm just going to might actually make the put an option into the graphics converter to do this, but for now we'll do it by hand. Yeah, it's 18. Should be able to do this. Yeah, pass, that's okay. There's a better way of doing this with macros and things, but I think what I will do is put it into the converter as an option. We know there's, again, we could use a macro to do it, but we know there's 34 tiles. So 0, 1, 2, 3, 4, 5, 6. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. One thing you can't do in this editor, or I don't know how to do in this editor, in Visual Studio you can select a column of text, so I could highlight all the ones and just press 2 once. It's much quicker. We've only got 34, so we only need 0 to 33. Okay, so that just gives us a quick lookup table. Data maze.s and lookup tables. Need to just delete these because we don't actually need them. It's only because I compiled the file. Just check it built. Here we go. What I might do actually is another file called include, except I don't want it there. I want it back in the main folder. Spelled it wrong. And we will copy lookup table one into there instead. Yes, that'll be where we put our extra files. So I just pressed F10 just to test how we're getting on. You see it's moaning because I haven't saved the file, as I was saying earlier. If I now save it, there we go. Assuming we pass in the tile, so on this A will equal tile number. D will equal the Y position in tiles. E will equal the X position in tiles to render. So this only works. Actually, what we'll do, we'll just double it that way. Look up, get the start of the maze, look up list, add HL, DE, add HL, DE, LDHL, increase HL, LD. We'll change that slightly. Use BC. We could store DE, but we're passing in. But I'll use BC. It's clear. HL. I want load. HL. Oh, right. Now the start of the graphics. I'm going to be paging in the graphics into the screen into page 0, so now we need to work out the start address. So A with the Y position. A. Again, we could do a lookup table for this. So we now multiply by 2 because we want to multiply this by 6 to step down each row. But because they're only 128 bytes long, we can cheat. We only need to multiply it by 3, which is what that does. So we take our screen position, multiply it by 2, add it back, add the first one back again, so multiply it by 3, and store that into D. So let's put a comment just so we know what this is. Now multiply. What we're actually doing is multiplying D by 128 times 6, which is 256 times 3, and since we're using the high byte, we can just multiply through there. Now again, we need to add E is the X position, so load A with E. Again, there's 2 pixels per byte. We need 6 pixels, so there's 3 bytes. So multiply the X position by 3, 6 pixels, 3 bytes. Add A, E, LD, E, A. So DE should now be the screen position. Copy the data is simply a case of, let's do it the slow way to begin with. No, we may as well do it the quicker way. So we know that's copied one set of data. What we'll do in BC is we will store 128 minus 3. 128 is how much we have to increase each row, and obviously minus 3 because we've copied 3 bytes. So now we can just add. Annoyingly, the screen position's in DE. That's one thing I hate. Exchange HR. Always get them the wrong way around. This isn't the fastest way by a long shot. But it's fine. It works. So that's 2. I'm just going to write it out longhand. It's 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5, 6. I'll probably rewrite that at some point. It's not the fastest. Hopefully it'll work. Does what we need it to do for now to test. So we can now do LDA, let's put A as 1, our initial power pill. D0, let's load E with 0. And call render draw tile 6x6. And then at the end, let's get to loop. Obviously, one thing we need to do, another function. We won't have a function for this at the moment. What we will do is down, I'll create a new file actually called variables. Render buffer, or render page, let's call it. DB. Let's use page 15. We can change these later. So this is the one we're going to render to. I'm just going to leave it that. We'll cover double buffering and things later on. So up here, what we're going to do is set our draw page and view page. So read, I think. If we go back up to, we're paging this into lower memory, LMPR, here we go. We need to set bit 5 because we want to replace the ROM. That's why we've done the DI at the start, so no ROM's calling. And it's 250. So that first LMPR to the render page. Set the view page, so render page. Now the VMPR is up here. We also need to set the graphics mode. So want bytes 5 and 6 to be our graphics. So we want to or in 6 0. We could do it in binary. We could go 0 1 1 0 0 0 0 0. If people prefer, whichever you prefer. I'm going to stick it to 6 0 251 252. Should remember by now. So save that. We're not including our variables at the bottom. Mouse rollable is not working very well. It's annoying. And again, I've put it in the wrong place. That should be in our includes folder. That's appeared in the wrong place. Oh, can't use page 15. Page 14. Oops. This is one other thing that annoys me. I wish I could set which file I wanted. This is why I use batch files more than this sort of thing. I do like this plugin. I tried a few, but it'd be nice if you could specify which file you want it to always compile, because you always have to go back. So we've still got a shatter on that. So what's going wrong with our drawer? Oh, of course. Because we've written out longhand, we can't store that there because LDI will decrease BC. So let's say this function I'm going to rewrite because it's not particularly fast, not particularly nice to look at, but just to do our test, that should be right. The palette's also wrong, so we should have black. Oh, that should be 16. What we could actually do is use actual length and just write the ones we need to. Probably better. Remember -1 because we want to start for the last palette entry. Length, so we know how many we're going to do. Right, let's just give that a... there we go, we've got a little power pill. We've also got this data down here, which is me doing the classic mistake. Because we're using page 0, that's where the stack pointer is. Makes more sense for us to have our own stack pointer somewhere we know where it is. That should solve that problem. There we go, got a little power pill. We can check that's working. We can change the graphics. So if we go to, say, graphic 3, which should be the first little corner. There we go. What we could also do is go LD D comma 0 LD E comma 1. Move across to the next tile. LD A comma, let's do 4. And look, we can start to see the maze appear. Obviously, we're not going to do this that way. Let's remember X, Y, so push DE, and then here we want to pop DE because it'd be useful if it didn't change. Now what we can do is we can write a little function called render tile map. Pass in HL tile map address B equals width in tiles and C equals height in tiles, and this will render. So what we'll do is we'll now draw maze. We will need to pass in let's pass in tile map lookup address. So D we will make at the moment we're just rendering maze tiles. What would be better is if we passed that in. So this comes out of this loop now. And let's remember it as well. I don't tend to store everything in every routine. I tend to sort of just think about which ones are going to be the most common things I'm going to need when using this routine. So B is going to equal, and C is going to equal width. Now we can call render tile map. Okay. We're going to need a width decrease. Going to loop with the width and right. Every time we come into here, we're going to want to remember to store new widths to run through, and this will call render draw tile 6x6. Okay, so loop through all the vertical, set the width counter, loop through all the horizontal. Okay. Now DE is the maze lookup, but that needs to come HL in here. So we're probably going to need D to say with which tiles we've got. Things like that. So let's call this the good thing with this, we can do some nice little self-modifying code. So brackets underscore tile lookup. Could switch which one we pass in. Or was that just me being stupid? Yeah, that's good. So I thought it was a. It's better. Sometimes I forget what instructions there are. So basically, we're just storing this down here because every time we call this function, we're going to need to pass it into HL. I'll leave the story in there as well. Okay. Now we've done that, we can do LD. Oh, I don't want that pixel need resets. H to we will hit LDD, 0. And then every time we come in here, we want to reset E to 0. Move on to next line, so we want to increase D. Move on to next tile, so increase E. So that will set our D and E each time. Want to read our tile into A, increase HL. Push HL there. Could use IX, but can work out which is quicker. Pop HL. So we're reading in the read the tile we want. Storing it because we're about to change it here. We can't use HL. We could use IX as we run out of registers effectively. With BC's the loop counters, DE is the tile position, HL is the tile set. So yeah, so we've run out of registers. We could hardcode the tile set in here. I'm trying to keep these slightly generic. We may need them for other tile sets. So just push it, pop it, no problems. I think that's all we need to do. Oop. Went very quickly. So let's just check what we're doing. Push BC. Reset B here because we're using it again here. The width loop go through, read one, render it, move on to the next one. That clears it down. Looks like it should be alright. Something's obviously wrong. Well, easiest way to... I suppose what we didn't do is check that the vertical position changes was right. Let's only render one line. See what happens there. That still vanishes very quickly. So put it back in. Of course. We're using BC in the counter, but we're not storing it inside this tile, and we're using it. Therefore, it gets corrupted. So we render our map down to a point. This thing is check this. It's interesting. Our map data gets to a certain point and then just exports blank data. Okay, if you've been watching the graphics converter tool playlists, you'll see there was a bug in the converter, which we've hopefully now fixed. So if I rerun this, there we go. We've now got the rest of the data. It's the fun with doing multiple projects and things at the same time. Always worth checking your data, because this was a more vertical and horizontal tile map. So if we now recompile, there we go. You can see we've got all of our map rendering. Yeah, so that's a good start. As I say, this isn't a particularly nice function. We're not really doing much as a main loop or anything. Code-wise, literally just testing some render tile routine and a render tile map routine, which are going to become quite important. But it gets us up and running. And next, what we'll do is we will look at grabbing some sprites and maybe putting some sprites on the screen. And then we can get basic first thing, just to get Pac-Man to move around the screen, animating and colliding as expected. That will probably take another video or so, but for this one, I think that's enough to stop. So yeah, see you in the next video.